Welcome to Narayana online classes. Let us see some problems in work power energy today. Yes, first question. Let's see here, a block of mass 1 kg is released from point A on a smooth track as shown. Part of AB is circular with radius R1, 4 meter, and circular at C with radius R2. Height h1 is 2 meters given to you and h2 is 1 meter given to you. Then the force exerted by block on the circular track at B is. So see here. When it is going downward, so here it is the part of a circle he is telling you like this. This is the part of a circle with the radius R1. R1 is equal to how much? 4 meters given to you. So here this radius is 4 meters given to you, that radius. Now here it is at a height h. When it is coming downward, it loses potential energy, gains the kinetic energy. So definitely it will be having some velocity v. And now what is that? The force exerted by block on the track is, what are the forces? Normal reaction upward, then its weight definitely downward, mg, and centrifugal force, mv square by r it is. Centrifugal force, that is, once again let me write, mv square by r. What is that radius? R1 is given. Let me take this is R1. And we need to find what is the velocity. So it is coming down by a height, from a height h1. So mg h1 is equal to half mv square I can write. First I will find what is the velocity. Thereby I will find what will the reaction force acting on the track it is. So that is, for finding the velocity, mgh is equal to half mv square it is. M cancel. Gravity. Height is equal to h1 will be equal to, h1 is equal to 2 meters. Gravity is 10. 2 half v square it is. So v square is equal to 40 it is. And the force exerted by the block on the track is n is equal to mg plus mv square by r1. mg plus mv square. When the force exerted by block on the track is normal reaction, it is mg plus mv square by r1. What is the radius r1 value? R1 is equal to 4 meters given to you there. Yes, substitution. What is the mass of the body? Sorry, mass of the body 1 kg it is. Yes, substitution. N will be equal to 1, 10, 1, radius is 4, v square is 40 it is. So 4 tens it is. So then normal reaction will be equal to 20 Newton it is. That is the reaction force acting at point B it is. So loss in potential energy will be giving you kinetic energy. Kinetic energy means velocity we can get. So that normal reaction is equal to mg plus mv square by r. We'll be getting the required answer for that. And next question. The work done by the gravitational force from A to C. The same diagram here it is. This is the diagram given to you. This diagram, from this diagram, so to move from A to C, what is the work done by gravity? He is asking you. Please see that one. So let me show you the diagram here. It is initially like this, going and reached here. So here it is h1 height, and here this is h2 height it is. This is point A and this is point C it is. The work done by gravitational force from A to C it is. So now A to C it is. So A to C means work done by gravitational force. Initial height is mg h1 minus final height is mg h2 it is. So then mass is 1 kg, gravity 10, h1 minus h2. So what is h1 and h2 values? h1 is equal to 2 meters, h2 is equal to 1 meter it is. Let me substitute that one. 10 into 2 minus 1 it is. So that is 10 joules it is loss. So the work done by gravitational force from A to C it is. Like this we can get it. And next question, let us go for, a particle moves on the rough horizontal ground with some velocity v naught. If 3/4 of its kinetic energy lost due to friction in time t naught, he is telling you, then the coefficient of friction between the particle and the ground is. So kinetic energy initial. Kinetic energy initial is equal to half m v naught square. Initial velocity is v naught. If 3/4 of its velocity, its kinetic energy lost due to friction. 3/4 lost. Now what is the kinetic energy final? Kinetic energy final will be equal to 3/4 lost, 1 minus 3/4 of kinetic energy initial. Loss. Then what is the present kinetic energy? It is, that is 1/4 of kinetic energy initial is half m v naught square. So kinetic energy final means half m v square. Let me write that equal to 1/4 half m v naught square. I can write one step. Let me write clearly. So then half m can cancel. Then v will be, final velocity is equal to v naught by 2 it is. You see once again, that is v is equal to v naught by 2. V square is equal to v naught by 4. Then v will be equal to v naught by 2. So initial velocity v naught, final velocity is v naught by 2. And next what he is telling you, if the kinetic energy is lost due to friction in time t naught, then what is the coefficient of friction between the particle and the surface? See here, let me show you a diagramical view. This is the particle. Initially it is started with velocity v naught, and after some time t naught, its velocity becomes v naught by 2. Within time t naught, he is telling you. So as this is moving this side, so friction will be acting this side. Friction will be in backward direction. Then the force, only force on that block is friction. So F is equal to ma is equal to minus friction. It is of course opposite direction. So that means minus mu mg. Ma it is. M cancel. So A is equal to minus mu g. Of course friction is negative direction. So that's why negative sign. That's why the velocity is decreasing. Now we are very much familiar. V is equal to u plus at. Final velocity v naught by 2. Initial velocity v naught, final velocity v naught by 2 minus mu g into t naught of time t naught, yes. And this mu g t naught this side, v naught by 2 that side. Then it is mu g t naught is equal to v naught minus v naught by 2, that equal to v naught by 2 it is. So mu value will be v naught by 2 g t naught it is. This is the coefficient of friction between the particle and surface it is. And next, one more question. The total mechanical energy of the particle is E. The speed of the particle x equal to root of 2e by k is root of 2e by m. Find the potential energy. Yes, given total energy is equal to E. Total energy is equal to E. The speed of particle, speed is given to you. V is equal to root of 2e by m. Speed of particle is 1 by 2, no? That is root of 2e by m, I can write. So squaring on both sides, v square is equal to 2e by m. V square is equal to 2e by m. So then you can say half m v square. M this side, this 2 also this side. Half mv square is equal to E. Half mv square means kinetic energy. That equal to E it is. Now, kinetic energy value I got. Then what will be the potential energy? We are familiar that total energy will be equal to kinetic energy plus potential energy. We are very much familiar. Kinetic energy, total energy is equal to kinetic energy plus potential energy. So total energy value given is E it is, and kinetic energy we just solved, that is E, and plus potential energy it is. So then energy will be cancelled, then potential energy will be equal to 0. So potential energy will be equal to 0 it is. So that is the answer for that. And next one. Next question. Yes, comprehension given to you. Potential energy is given to you, is given by potential energy. U is equal to AX plus BY. AX plus BY given to you, where A and B are constants. The mass of the particle is 1 kg. Mass of the particle is 1 kg given to you. And next, X and Y are coordinates of the particle in meters. The particle is at rest at 4A, 2B. The points, initial points x1, y1 is equal to, this is at t equal to 0, x1, y1 is equal to 4a, 2b. These are the points initially. So that is the information given to you. Now what is the first question? Find the speed of the particle when it crosses x-axis. It is crossing x-axis means y value will be equal to 0. So initially y1 is 2b, and for the 31 y value will be 0. So now it is moved a displacement. How much displacement is moved? Initially at 2b position, finally it is at 0. So y1 is equal to 2b, y2 is equal to 0. And that is the first information. And next, potential energy is given to you. Thereby we can find what is the force is, please. So given U is equal to AX plus BY. AX plus BY. Then force F is equal to minus dou U by dou X I minus dou U by dou Y J. Because x and y components only present, so that's why only x differentiation, y differentiation I am going for. Then F bar will be equal to dou u by dou x minus ai minus a j it is. Minus ai minus aj. Mass is equal to 1 kg now, then acceleration will be equal to m into a bar is equal to minus ai minus bj. So from this m is equal to 1 now, so a bar is equal to minus ai minus bj. So this is axi ay j it is. So ax is equal to minus a, ay is equal to minus b it is. So now points, if you see, initially 2b position, finally 0. So it has traveled a displacement to be along y-axis. So for that what I am going, Sy is equal to uyt plus half ay into t square. I want to find what is the time taken to move that much displacement. So what is the displacement? Initially it is, initial position is 2b, finally is 0. So that means it has traveled minus 2b is equal to y2 minus y1 is equal to 0 initially at rest, half ay minus b into t square it is. So then it is minus 2b, one more step let me write clearly, is equal to minus b by 2 into t square. Negative, negative gone, b also gone, then t will be equal to 2 seconds. So this is time taken to cross x-axis he is telling you. To cross x-axis it is taking 2 seconds. So then initial velocity, it is at rest. So then Vx is equal to ux plus ax into t. What is initial velocity? Vx will be equal to 0 plus ax. What is that ax? Minus a. Minus a into 2 it is. So Vx will be equal to minus 2a. Similarly, Vy is equal to uy plus ay into t it is. So Vy is equal to uy is 0 minus ay is equal to minus b it is, yes, into 2 it is. So Vy will be equal to minus 2b. Then what will be the velocity? V is equal to root of Vx square plus Vy square it is. So V will be equal to Vx square, it is 2a whole square, 2a square plus 2b square it is. Then 2 square taking common, this is 2 root of a square plus b square. That will be the velocity when it is crossing the x-axis it is. So like this we can solve. Next question. Yes. Same potential energy given to you, then same comprehension in that another question it is. Find the speed of the particle when it crosses y-axis. When it is crossing y-axis means, before going to that, what is ax and ay values already we got? Solution. U is equal to, what is that? Ax plus by. Ax plus by. F bar is equal to minus ai minus bj it is. So from here ax is equal to minus a, ay is equal to minus b. Just before question, just continuation, one more question in that. So that is ax and ay. Now what is that? It is crossing y-axis. It is crossing y-axis means x value will be equal to 0. Initially x1 this is. So x1 initially it is at 4a, finally it is at 0. Then the displacement is equal to 0 minus 4a, that equal to minus 4a is the displacement. So Sx is equal to uxt plus half ax into t square. S is equal to ut plus half a t square I can write. So Sx is equal to what? Minus 4a is equal to 0. Ax is equal to minus a, minus a by 2 into t square it is. One more step let me write 4a. Minus 4a is equal to minus a by 2 into t square I think. Once let me see that one. Minus 4a is equal to minus a by 2 into t square it is. Minus a by 2 into t square. Yes, what we can write? A cancel, negative sign also gone. Then t is equal to 2 root 2 seconds it is. That is the time taken to cross y-axis it is. So then again velocity along x-axis, Vx is equal to ux plus ax into t. So Vx will be equal to ux 0, ax is minus a, time is 2 root 2 it is. Then Vx will be equal to minus 2 root 2 a it is. And similarly Vy will be equal to uy plus ay into t it is. Then Vy will be equal to 0 minus b into 2 root 2 it is. Then Vy will be equal to 2 root 2 minus 2 root 2b minus 2 root 2b it is. So then here it is Vx and this is Vy. Then velocity is equal to root of Vx square plus Vy square it is. Then V will be equal to 2 root 2 a whole square plus 2 root 2 b whole square under root. So the 2 root 2 I can take out as it is whole square it is under root of a square plus b square. This will be the velocity when it is crossing the y-axis value. Yes. Next one. Again the same thing. Find the coordinates of the particle at t equal to 1 second he is asking you. Initially what is that given to you? Again u is equal to ax plus by. F bar is equal to minus dou u by dou xi minus dou u by dou y j it is. So F bar is equal to minus ai minus bj it is. So then what I can write? Ax is equal to minus A, Ay is equal to minus B, I can write. So that is Ax and Ay values. Initially, x1 comma y1 is equal to 4a comma 2b. That is the initial ordinates it is. So this is x1, y1, that is the values. And after 1 second, what will be the coordinates he is telling you? Yes, 1 second. So here we are having the acceleration along x-axis, acceleration along y-axis also we are having. So after 1 second means Sx is equal to uxt plus half ax into t square it is. Sx is equal to 0 plus half ax is equal to minus a into 1 square it is. So then Sx will be equal to minus a by 2 it is. And next similarly, Sy is equal to uyt plus half ay into t square it is. Sy is equal to 0 plus half ay means minus b into 1 square it is. So Sy will be equal to minus b by 2. Now, in 1 second it is travelled minus a by 2 along x-axis. But what is the initial position? X1 is equal to 4a. So x1 is equal to 4a. Initial position is this thing. Then what is x2 is equal to x1 plus sx it is. So that is 4a minus a by 2 it is. So then what is that? 8 minus 1, 7a by 2 it is. That is 3.5 a it is. Similarly, x2 will be equal to, not x2, sorry. See here, here it is. Y1 is equal to, what is that y1 value given? Y1 is equal to 2b given to you. Then y1 is equal to 2b. So y2 is equal to y1 plus sy. So that equal to 2b minus b by 2 it is. So y2 will be equal to 2 to the 4, 3b by 2, that equal to 1.5 b. Then final ordinates are x2 comma y2 will be equal to, x2 value is 3.5a, 3.5a comma 1.5b. This is the final coordinates of that particle after 1 second. So 3.5a, 1.5b it is. Next. Comprehension 3. In the figure, the variation of potential energy of particle of mass m is equal to 2 kg is represented as shown like this. X coordinate, the particle moves along x-axis with conservative force acting. Then, if the particle is released at the origin, then it will move towards positive x-axis, it will move towards negative x-axis, it will remain stationary at the origin. So here, it is here. It is having the potential energy at this position. If the particle released at the origin, then, so see here. So here in this equation, we don't know whether the force is acting which direction, whether the force is pulling that body or the force is moving away. So as the force which direction it is acting, we are unable to tell you. So from that information, we cannot say which direction the body can move. So it's a subsequent motion cannot be decided due to lack of information. If the direction of force is mentioned, then we can say it is. So as the direction of force here unable to tell you, so we cannot say which direction it can be moving. It may be at rest, it may be along x-axis moving, positive x-axis it may be moving, maybe it is moving negative x-axis also. We cannot predict that one because the information is insufficient, so we cannot take the chance there. That is about it. Next. In this figure, mass is again 2 kg, particle is moving. Okay, continuation in that. Now, x is equal to minus 5 meter. So here it is x is equal to minus 5 meter and x is equal to 10 meter it is. This is x equal to 10 meter position, x equal to minus 5 meters position it is. Positions of the particle are respectively of. So okay, whether they are stable equilibrium or unstable equilibrium or neutral equilibrium he is telling you. So here it is like this. So here this is the point, this is the position of stable equilibrium it is. Stable equilibrium. If we disturb this one, the body is trying to come to original position, so that is stable equilibrium position it is. And next, as it is potential energy and x graph it is. And next if I go for here, potential energy minimum position. Potential energy minimum, that is stable equilibrium. And if you go for position 10, this is 5, position 5 it is. And if I go for position 10, you can see that one there, it is graph is like this. So this is potential energy maximum it is. Potential energy maximum means that is unstable equilibrium we can say. So potential energy minimum position stable equilibrium, potential energy maximum position is unstable equilibrium we can say. So obviously x equal to minus 5 means potential energy minimum. So that is stable equilibrium. So stable. And then x equal to 10 means that is unstable equilibrium, stable and unstable equilibrium. So this is the answer for that. Yes, that is the thing. And next, a body of mass 6 kg is under the force causes the displacement S is equal to t square by 4 meter given to you, where t is time. The work done by the force in 2 seconds is. Work done by the force in 2 seconds he is asking you. So please see that one. S is equal to t square by 4 given to you. S is equal to t square by 4. Then what will be the velocity? V is equal to ds by dt. That equal to V is equal to ds by dt it is. So ds by dt means 2t by 4 it is. That equal to t by 2 it is. V is equal to t by 2 it is. So then V1 is equal to, that means time where it is changing from, where t is the time, the work done by the force in 2 seconds. So t equal to 0. Initially t equal to 0, V1 is 0. Next at t equal to 2 seconds, V2 it is. That will be how much? 2 by 2. That will be 2 by 2, that equal to 1 meters per second it is. Then work done he is asking you, work done is equal to k final minus k initial it is. So half m V2 square minus V1 square, of course mass it is. So then half, what will be the mass value? Mass is 6 kg given to you. Then 6 into V2 square minus V1 square. V2 is 1, okay. 1 square minus 0 square it is. So that is 3 joules it is. So this is the answer for that. So if at all displacement is given, thereby find the velocity value. Thereby velocity change in kinetic energy will give you what is the work done by that force it is. And next, one more question. An object is acted on by a retarding force 10 Newton. And at a particular instant, its kinetic energy is 6 joules. The object will come to rest after it has traveled a distance of. After it has traveled a distance of. Initial kinetic energy is 6 joules given, and it is having 10 Newton force it is acting. It has traveled a distance of. So, work done. Again, work done by retarding force. Work done by retarding force is equal to k final minus k initial I can write. So work done by retarding force is equal to F into displacement. Of course, negative sign I can write. That equal to k final 0, k initial. Okay, on step let me write clearly. K final. It is coming to the object will come to rest. Come to rest means obviously final kinetic energy is 0. Minus 6 joules it is. Yes, what is the force value given to you? 10. Minus 10 into S is equal to minus 6. So then S is equal to 6 by 10. Then displacement is equal to 3 by 5 meter. After traveling a distance 3 by 5 meter, it will be coming to rest. So after traveling a distance of 3 by 5 meter, it will be coming to rest it is. So that is about it. Next one. Yeah. The kinetic energy of a body is K if 1/4 of its mass is removed and velocity is doubled, its new kinetic energy will be. We are very much familiar that kinetic energy will be equal to half m v square it is. So kinetic energy 1 by kinetic energy 2 will be equal to m1 by m2 into v1 square by v2 square it is. v1 square by v2 square it is. What is m1? m1 is equal to m. What about m2? What he is telling you? If 1/4 of the mass is removed, 1/4 is removed means then m minus m by 4 is the present mass. That equal to 3m by 4. And next what is that? V1, V2 is doubled. So V1 is equal to V, then V2 is equal to 2V it is. Then by substituting those values, then what it will be? K1 is equal to K. K1 is equal to K. K2 is asking you. As let us substitute the values. K by K2 will be equal to M1 is M, M2 is 3M by 4. M by 3M by 4 into V square by 4V square. V square by 4V square. V square gone, M gone. Of course, 4 is also gone. Then K2 will be equal to 3K it is. K2 will be equal, new kinetic energy will be 3K it is. So like this, we can solve kinetic energy equal to half m square, just ratio taking, we'll be getting the required answer for that. Next one. Yeah. A force of 4x square plus 3x Newton acts on a particle which displaces it from x equal to 2 meters to x equal to 3 meter. The work done by the force is, what will be the work done by the force? So here if you see the force, this force is F is equal to, what is that? 4x square plus 3x it is. F is equal to 4x square plus 3x acts on a particle which displaces it from 2 meters to 3 meter it is. So now here the force is a variable force. F is variable. F is variables. So then work done will be equal to integration of F into dx it is. F will be equal to integration of, work done will be equal to F into dx it is. So then work done will be equal to integration of F into dx. F is equal to 4x square plus 3x into dx 2 to 3 it is. So then work done will be equal to 4 x square differentiation integration is x cube by 3. Where to where? 2 to 3 plus 3 into x square by 2. That is from 2 to 3. Now the limits I am substituting there. For that, going to next page. So that is 4 by 3. Then work done will be equal to 4 by 3 into, so what is the upper limit and lower limit? X cube 3 to know, so that means 3 cube minus 2 cube it is. So 3 cube upper limit minus lower limit it is plus. So 3 by 2 x square no, 3 square minus 2 square, yes. 3 by 2 that is 3 square minus 2 square it is. One step clearly, let us write 4 by 3, 3 cube, 9 into 3, 27 minus 8 it is, plus 3 by 2 into 3 square 9, 9 minus 4, 5 it is. So then what I can write here, 27 minus 8, it is 19. So 4 into 19 by 3 plus 3 into 5, 15 by 2 it is. So then let me take this LCM by 6 LCM taking. 19 4 just 76 it is. 76 into 2. 76 into 2 it is. 2 6 of 12, 7 of 14, 15 it is. 152. So 152 plus 15 3 of 45 it is. So then work done will be equal to 150 plus 45, 195, 197 by 6 it is. So then work done will be equal to, then what is that? 6 1 ja, 6 3 ja 18, 6 3 ja 18, 1 remains, 6 2 ja 12, and then 5 remains, 32.5 means 6 8 ja 48. So that is work done is equal to 32.8 3 it is, joules it is. So this is the work done by it. So 32.83 it is. 32.83, yes. This is the answer for that. Like that we can solve. Next question, let us go for yes. Thank you so much.